The Moon has been keeping a secret. In June 2024, less than 2 kilograms of it reached Earth for the first time. China's Chang'e 6 returned samples from the far side, the hemisphere that has never faced Earth in all of recorded human history. Scientists expected the rocks to confirm what 60 years of models already predicted. They did not. The far side erupted for over 1 billion years without the heat source that powered all known near-side volcanism. There are several explanations. Some of them almost work. None of them close the case completely. Every gram of moon rock ever studied before June 2024 came from the same hemisphere. Apollo brought back 382 kilograms across 6 landing sites, all on the near side. The Soviet lunar missions returned small amounts, also near side. China's Chang'e 5 mission in 2020 collected 1.7 kilograms, near side again. Orbital missions had mapped the far side with radar and gravity instruments. Scientists could see its surface, measure its topology from orbit, estimate its composition through spectral analysis. But nothing had ever been physically collected from it and returned to Earth. Everything known about how the Moon cooled, how its interior evolved, how volcanism began and ended, all of it was assembled from one half of a two-sided body. That is not a minor gap. That is the equivalent of forming a complete diagnosis of a patient by only examining one side of their body. The near side and the far side look different even in photographs taken from orbit. The near side is covered in dark volcanic plains, the Maria, the ancient lava seas visible to the naked eye from Earth on any clear night. The far side is heavily cratered, pale, a rougher and more ancient-looking surface with almost no visible dark regions. The difference was obvious from the first photographs returned by the Soviet Luna 3 probe in 1959. And for decades, the explanation seemed sufficient. The near side faced Earth during the early solar system, received additional heat from a geologically active young planet, stayed warmer longer, and allowed volcanic eruptions to resurface it repeatedly over billions of years. The far side cooled faster, stayed older. A simple thermal gradient built into the geometry of the Earth-Moon system. That explanation, sometimes called the Earth-Shine model or the thermal asymmetry hypothesis, is clean, intuitive, and well supported by broad observations. It correctly predicts why the near side has more volcanic plains, why its crust is thinner, why its geological history appears more active. For 60 years, no physical material from the far side was needed to test it, because nothing had arisen to challenge it. The model was assumed correct, not because it had been verified from both hemispheres, but because only one hemisphere had ever been sampled. The possibility that the other side might tell a completely different story was a theoretical concern. Until June 2024, it had no evidence attached to it. On May 3, 2024, China's National Space Administration launched Chang'e 6 toward the Moon. On June 1st, the spacecraft set down inside the South Pole Aitken Basin, the Moon's oldest confirmed impact structure. A scar 2,500 kilometers wide and 8 kilometers deep, carved 4.25 billion years ago by a collision violent enough to punch through the crust and expose the deeper mantle to space. If that basin were placed over the continental United States, it would swallow every state east of the Mississippi River and press against the edges of the Great Plains. The lander drilled into the surface. It scooped material from the basin floor. On June 25, 2024, a return capsule descended through Earth's atmosphere and touched down in Inner Mongolia, carrying 1,935.3 grams, the first physical material from the far side of the Moon ever to reach human hands. The scientific papers arrived in waves. The first set appeared in November 2024, published in Science and Nature. 4 more came in July 2025 through the Chinese Academy of Sciences. Each one reported something real. Each one left something unresolved. The first finding sounded almost routine. The basalts in the sample, dark, dense volcanic rock, dated to approximately 2.83 billion years old. The far side had experienced volcanic eruptions. That was not, by itself, a surprise. The near side shows volcanic activity going back more than 4 billion years, with some eruptions as recent as 1 to 2 billion years ago. A 2.83 billion-year-old eruption on the far side fit comfortably within the expected picture of a geologically active moon. Then the geochemists looked at the chemistry, and the routine finding became a problem. CREEP is an acronym for potassium, rare earth elements, and phosphorus. It is not merely a chemical signature, it is a heat engine. When the moon's molten interior began to cool billions of years ago, these elements were among the last to solidify. They concentrated in the deepest remaining pockets of melt, eventually enriching the upper mantle beneath the region that became the near side. Over billions of years, the radioactive decay of elements within CREEP released heat, slow, persistent, continuous. That heat kept the mantle warm enough to drive eruptions long after the moon should have gone geologically cold. CREEP is why the near side stayed active. Remove it, and the mechanism that powered all known lunar volcanism disappears. It has been the foundation of lunar science for 50 years. The Chang'e 6 samples are nearly devoid of it. The heat source was missing. The volcanism happened anyway. This is not a rounding error. The CREEP signature is one of the most consistent geochemical features of near-side samples present in Apollo rocks from 6 different landing sites spread across hundreds of kilometers, reliable enough to serve as a chemical fingerprint for the entire near-side interior. Its near-total absence from the far-side material is not a small numerical deviation. It is the chemical equivalent of opening a running furnace, watching it burn for over 1 billion years, and then discovering that the fuel it required was never present. The simple model predicted that the near side would have more volcanism. That part is correct. What it did not predict is that the far side sustained eruptions spanning approximately 1.4 billion years, from 4.2 billion to 2.8 billion years ago, according to analyses published in July 2025, without the chemistry the standard model requires. 1.4 billion years of volcanic activity on a hemisphere that lacked the internal heat to explain it. For comparison, complex animal life has existed on Earth for less than 600 million years. The far side was actively erupting for more than twice that span, according to the geological record frozen in those rocks, and doing so with an interior that, by every known measure of near-side geochemistry, lacked the radioactive fuel to keep itself warm. There are 2 ways to read this. The first says the Earthshine model is mostly right. The broad prediction holds. The near side is more volcanic, the far side older and quieter overall. The CREEP puzzle might have a local explanation. The South Pole Aitken Basin, formed by an impact that stripped away much of the crust, may have thinned the surface enough to allow hotter mantle material to breach it more easily in that specific region. Some of the volcanism might trace back to impact dynamics rather than interior heat. This version keeps the existing model intact, adds complexity, but requires no fundamental revision of how the moon works. The second version does not offer that comfort. It says the far side did not simply cool differently, it may have formed from different material. Its mantle is depleted in the elements that define near-side geochemistry, not subtly, but significantly. Its volcanic history spans a time window that the current physics of lunar heat loss cannot cleanly account for. What the lander returned may not be a variation on the near-side story. It may be material from a deeper, older layer of the lunar interior, a layer the near side never exposed, because the near side never had a wound large enough to open it. That is where the creep problem left the case. Two versions, neither fully closed. The published literature described the situation with a single careful word: puzzle. And that puzzle had been sitting unreached for 4.25 billion years, in a crater the first human explorers never visited, on a surface that had never once faced the planet that eventually sent a spacecraft to touch it. Not anomaly, not error. Puzzle, the word scientists use when the data is real, the methodology is sound, and the model simply does not keep pace. But the volcanic history and the missing creep are not the only record preserved in those 1,935 grams. The same rock that lacks the expected heat source carries something else. A second measurement, frozen into the crystals at the moment the lava solidified 2.83 billion years ago. A record that no far-side material had ever provided before. And what it shows contradicts the models in a completely different way. Every model said that record should show a magnetic field in decline, fading towards zero. It does not. The magnetic field finding did not come from a separate mission. It came from the same 1,935 grams. The lunar dynamo, the mechanism that generates a planetary magnetic field, requires a liquid interior. Fluid motion in a molten core creates electrical currents, and those currents produce the field. Earth still has one. The Moon's is gone. Every model of lunar evolution agreed on the trajectory. As the Moon cooled, its interior solidified, the dynamo slowed, and the magnetic field declined steadily. By 2 to 3 billion years ago, it should have been fading toward nothing. Weak, then weaker, then silent. The far-side basalts tell a different story. When volcanic rock cools, magnetic minerals within it lock onto the ambient magnetic field at the exact moment of solidification. The same way iron filings align with a magnet and then freeze in place when the surrounding material hardens. The orientation and strength of that frozen record reveal what the field was doing at the precise instant the lava went cold. It is one of geology's most reliable measurement tools, and the record locked into the 2.83 billion-year-old basalts from the far side shows something no previous model predicted. At that moment in time, the Moon's magnetic field was not in decline. It had strengthened. It had come back. The term used in the Nature paper published in July 2025 is reinforced. A reinforced lunar dynamo recorded by Chang'e 6 far-side basalt. Not a dying field, not a weak remnant struggling against extinction. A field that had apparently increased in intensity at a moment when the standard cooling curve said the dynamo should have been in its final stages. The mechanism responsible is not known. The standard cooling story for a body like the Moon runs in one direction. Heat bleeds outward, the interior solidifies, fluid motion decreases, the dynamo quiets. Nothing in that sequence has a rebound built into it. But the record in the rock says something rebounded. That is not a modeling error that better data will smooth away. It is a physical event, preserved in crystal, waiting 2.83 billion years to be read, and it does not fit the sequence. The researchers who published the finding described the Moon's dynamo as having behaved in ways that current models of planetary cooling cannot fully account for. 3 separate findings now from the same 2 kilograms. The far side erupted for 1.4 billion years without the heat source that powered all known near-side volcanism. Its mantle lacks the chemical elements that define 60 years of near-side geochemistry. And the Moon's magnetic field, at the moment those far-side rocks solidified, was doing something no model of a cooling Moon was designed to accommodate. Then, the July 2025 papers added a 4th. The far side mantle is significantly drier than the near-side mantle, not marginally different in water content, significantly depleted. Water in planetary mantles is not surface water or ice. It refers to hydrogen incorporated into the crystal structure of minerals deep in the interior, a record of how wet or dry the original material was when the body first formed and differentiated. The near side mantle carries measurable water content. The far side, according to the analysis of Chang'e 6 samples, does not. The boundary between these two reservoirs, where the wet ends and the dry begins, how far down it extends, whether it represents two different formation environments or two different processing histories, is still unknown. What is not unknown is the asymmetry. It is real, it is significant, and it is one more way the two hemispheres of the same body are separated by more than distance. 4 contradictions, same sample, 4 different physics problems. That is the 4th version of the story, not about a single anomaly, but about what it means that a single landing site on a single hemisphere produced this many simultaneous breakdowns in the existing model. 6 decades of near-side science built a framework that seemed complete. The first physical material from the other side produced 4 independent reasons to reopen it. James Head, a planetary geologist at Brown University, wrote in June 2024 that without returned samples, scientists cannot fully understand the Moon as a complete planetary body. He wrote that before the papers arrived. This is where the strongest explanation enters and where it runs out. The South Pole Aitken Basin is 2,500 kilometers wide and 8 kilometers deep. It formed 4.25 billion years ago during the solar system's early period of heavy bombardment. Whatever hit the Moon to create the SPA basin was not a typical impactor. The crater it left is the largest confirmed impact structure on any rocky body in the solar system. The collision punched through the crust and drove deep into the mantle. Material that had been locked in the Moon's interior was excavated, thrown outward, and distributed across the far side surface. What Chang'e 6 returned may not be ordinary crustal material. It may be mantle material, the Moon's own interior, exposed by the violence of that ancient impact. That would explain the creep depletion, because creep concentrated in the near side interior, not in the deep far side mantle. It would explain the dry chemistry, because the deep mantle predates the processes that brought water into the near side system. It would explain why the bulk composition of the far side samples looks so unlike anything Apollo ever returned, while still being recognizably lunar. The SPA impact did not create a different Moon. It may? That is the most coherent single explanation for the geochemical character of those samples. Several research teams across the 2024 and 2025 papers have pointed toward it as the likeliest framework. The problem is that it explains the geology. It does not close the physics. If the SPA impact is responsible for the depleted, dry, creep-poor character of the far side material, it occurred 4.25 billion years ago. The magnetic field rebound occurred at 2.8 billion years ago. That is a gap of more than 1.4 billion years. A single ancient impact cannot be the direct cause of a dynamo fluctuation that happened more than a billion years later. Something kept the Moon's interior active and partially liquid long enough to produce not just sustained volcanism, but a renewed or strengthened magnetic field, at a moment when the standard cooling model says the dynamo should already have wound down. What that mechanism is has not been established. The impact theory explains the container. It does not explain what happened inside the container across the following billion years after the lid was removed. If you look at the Moon tonight, full or crescent, anywhere in its cycle, every part of it you can see is the near side. Every crater visible to the naked eye, Every dark sea, every feature that Galileo sketched in 1609, every landing site that Apollo crews walked across, every sample that has ever been analyzed in a laboratory, it all comes from one face. The far side has been rotating away from you for the entire span of recorded human history. Not occasionally, always. Locked into that orientation by tidal forces that settled billions of years ago, the other half of the moon has permanently faced away from Earth, seen from this planet only by spacecraft that flew past or entered orbit. The first 2 kilograms from that other face contain 4 contradictions to 6 decades of models. Each one operates on a different timescale, involves a different physical process, and points toward a different gap in the existing understanding. No single explanation currently available resolves all 4 simultaneously. The secret the moon was keeping was not one thing. It was several things, layered on top of each other inside the same deep mantle, inside the same volcanic rock, inside the same 1,935.3 grams that a spacecraft scooped from the floor of the moon's oldest wound and carried back to Earth. There are roughly 3.8 billion years of geological history locked into the far side surface. Chang'e 6 sampled one location inside one basin. The next far side sample return mission has not been scheduled. The volcanic record across the rest of that hemisphere, the water profile at different latitudes, the magnetic signal from different geological periods, the chemical fingerprint of regions untouched by the SPA impact, all of it remains in the dark, in rock that has not moved in billions of years, on a surface that, in all of human history, only one spacecraft has ever physically touched. The moon rises tonight, as it always does. It crosses the sky. It sets. The same face turns toward you that turned toward every human who ever looked up at it, every astronomer who mapped its craters, every person who ever stood in a field and watched it come over the horizon. The other half is still out there, facing away from Earth, as it always has. And the first 2 kilograms from it were enough to rewrite the model. What the rest of it contains is still locked in the dark.